The universe is almost impossible to wrap your head around. When you go outside and look up at the night sky, you're staring into a vastness that basically breaks human comprehension. There are billions of galaxies out there, and within every single one of those galaxies, billions of stars. Actually, there are literally more stars in the universe than there are grains of sand on every single beach on Earth. Just let that sink in for a second. And we now know that a ton of those stars have planets orbiting them too. The numbers are so staggeringly huge that they almost start to lose their meaning. Welcome to this explainer on Curious Orbit. Today we're going to dive into a mystery that spans the entire cosmos. Because of those mind-boggling numbers, there's one specific question that has haunted scientists for decades. It was famously asked by the physicist Enrico Fermi. He basically just looked at the sheer mathematical probability of a universe this immense and asked, where is everybody? It's such a brilliantly simple question, but it carries this really haunting weight. If the universe has had billions of years to create intelligent civilizations, shouldn't our cosmic neighborhood be absolutely bustling with life by now? The universe has billions of galaxies. So where is everybody? We're looking out into an unimaginably massive cosmos, completely filled with the raw ingredients for life, and yet all we hear back is absolute, deafening silence. It is this profound disconnect between what our math tells us should be out there and what our eyes and ears are actually observing. Part 1. The ultimate cosmic mystery. If you think of the cosmos as a massive detective story, this number right here is our first big clue. We have a universe full of prime real estate, but our primary suspects, alien civilizations, are just completely missing. We're out here searching for any footprint in the cosmic dust, but the trail is incredibly cold. See, the universe is roughly 13.8 billion years old. Earth, our home, is just one single planet that formed much, much later in the game. So the logic seems pretty straightforward. If intelligent civilizations appeared elsewhere in the universe, some of them could have easily had a head start of millions or even billions of years to develop advanced technology. Millions of years of progress. Just imagine where humanity was 1,000 years ago and then project that forward by 1,000,000 years. Now, for thousands of years, humans just looked up at the stars and wondered if we were alone. It was purely a philosophical thing. But modern astronomy changed absolutely everything. We didn't have to just guess anymore. We actually discovered that planets are incredibly common. We've detected thousands of exoplanets orbiting other stars. And some of these are rocky worlds, kind of like ours, hanging out in regions where liquid water could potentially exist. So with all these possible habitable worlds identified, the existence of alien life went from being a fun sci-fi concept to a very, very serious scientific question. Part 2. The Fermi Paradox. And that brings us to the official name for this profound tension, the Fermi Paradox. It's that massive contradiction between the high mathematical probability that extraterrestrials exist and what we actually see, which is no alien signals, no giant space structures orbiting distant stars, no clear signs of advanced civilizations moving across the galaxy. Nothing. Despite the billions of years and billions of planets, the evidence is just completely non-existent. This right here is the core of the Fermi Paradox, and it sets the stage for some incredible and honestly sometimes terrifying scientific theories trying to explain this silence. Part 3. The Great Filter Theory. Okay, so one of the most fascinating explanations in all of science is the Great Filter Theory. This idea suggests that there is a major, nearly impossible obstacle standing in the way of life. The theory goes that somewhere between the emergence of simple life and the development of an advanced spacefaring civilization, there's a barrier, a filter. Imagine the development of a galactic civilization as a series of evolutionary steps. First, a suitable planet forms. Then life begins. Then complex organisms appear. Next, intelligence develops. After that, a civilization creates advanced technology. And finally, that civilization becomes capable of spreading out across the galaxy. The Great Filter Theory suggests that one of these specific steps is extremely difficult, like almost impossible to pass. And this creates a pretty terrifying existential fork in the road for humanity. Could the filter be behind us, or is it ahead of us? Now, there's a hopeful possibility here. Maybe the hardest step already happened. Maybe creating life from non-life is just incredibly rare. Or perhaps the leap to intelligent life is what's super uncommon. If that's the case, humanity might have already passed the most difficult barrier. The fact that we're here at all would mean the universe allows intelligent civilizations to emerge. We just happen to be the really rare survivors. But there's another, much more concerning possibility. The filter could still be ahead of us. What happens if the filter is in our future? What if a lot of civilizations reach our exact level of technology, but then just fail to survive? They might invent incredibly powerful technologies before they actually learn how to handle them safely. Advanced civilizations could face insurmountable challenges. We're talking massive resource depletion, irreversible environmental changes, or other self-inflicted global catastrophes. If civilizations usually wipe themselves out before they can deeply explore space, well, that would perfectly explain why the universe seems so empty today. Then again, another possibility is a lot simpler. Maybe intelligent life is just extremely rare from the get-go. The universe could be full of planets with simple life, sure, but only a tiny, tiny fraction ever develop civilizations that can communicate across space. Earth itself is a perfect example of how many wildly unlikely events had to happen perfectly in sequence for us to be here. We have a stable star, a suitable planet, liquid water, complex chemistry, and billions of years of totally uninterrupted evolution. Perhaps the recipe is just way too difficult. Like, meeting a giant gas planet like Jupiter nearby just to act as a shield and protect us from constant asteroid strikes. It could be that intelligent civilizations are just incredibly uncommon because the exact conditions are nearly impossible to replicate. Part 4. The Silent Universe. Now, humanity hasn't just been sitting back and guessing. We are actively listening to the stars. Scientists have been searching the sky for signs of intelligent life through projects like SETI, which is the Search for Extraterrestrial Intelligence. Basically, these are dedicated scientific projects that point massive satellite dishes at the cosmos, listening for artificial radio signals coming from distant worlds. We're hoping to catch a broadcast. But so far, we haven't confirmed a single alien transmission. However, we really have to remember the scale we are dealing with here. Space is enormous. Our searches have only explored a tiny, microscopic fraction of possible locations. Finding another civilization out there could be much harder than finding a needle in an ocean. It's not just a haystack, it's an ocean of stars, and we have literally barely dipped our toes in the water. And there's another massive hurdle, our own imagination. A civilization that is thousands or even millions of years ahead of us might not communicate in ways we can even begin to understand. They might use technologies we simply cannot detect yet. Their signals might not look anything like the radio waves our scientists are currently searching for. So the universe might not actually be silent at all. We just might not know how to tune in yet. There's also a much more unsettling idea as to why we don't hear anyone. Some theories suggest that advanced civilizations might intentionally avoid revealing themselves. Why? Well, because they have no idea if other civilizations out there are friendly. A civilization could actively choose absolute silence as a strict survival strategy. This concept is called the dark forest hypothesis. It pictures the universe as a dark forest at night, where hunters are quietly creeping through the trees, and the smartest thing you can possibly do is stay completely quiet. Now, it's very important to note that this is a highly speculative idea, not a proven scientific fact, but it definitely gives you chills, right? Part 5. Humanity's Uncertain Future. Ultimately, exploring all these mind-bending cosmic theories brings us right back down to Earth. Literally, what happens when a civilization becomes powerful enough to affect its entire planet? Technology gives us these incredible, almost godlike abilities, but it also creates brand new existential challenges. The ability to actually travel into space requires a lot more than just incredible engineering. It requires long-term survival. Becoming a true spacefaring civilization means solving social and environmental problems that go way, way beyond just building bigger rockets. So the Great Filter isn't just about finding aliens. It's a mirror. It's about understanding ourselves. Are civilizations common, or are they short-lived? Can intelligent life survive long enough to explore the universe? Asking these questions helps us think critically about humanity's own trajectory. Maybe somewhere out there in the galaxy, another civilization is looking up at their own stars and asking the exact same question. Maybe the universe is absolutely teeming with life. Maybe we're just incredibly rare. Or maybe the hardest challenge is still waiting for us ahead. The truth is, we just don't know. And that uncertainty is exactly what makes the search for alien life one of the greatest mysteries in all of science. What do you think? Are we alone in the universe? Comment your theory and subscribe to Curious Orbit.